All right, let's talk about a super powerful statistical tool that every data person should have in their back pocket, ANOVA. If you've ever been stuck trying to compare, say, 3, 4, or even more groups all at once, then you're in exactly the right place. Let's dive in.
So first, let's set the stage a little bit. In the world of data and stats, comparing the average of two different groups is like a classic move. But what happens when things get more complicated? What happens when you need to look beyond just a simple pair?
I mean, z-tests and t-tests are fantastic, don't get me wrong, but they're built for a very specific job, comparing one group to another, A versus B. They're designed for pairs. So what are you supposed to do when you've got 3 different teachers you want to evaluate, or 4 different marketing campaigns, or maybe 10 different manufacturing processes to analyze? You can't just run a bunch of t-tests. That gets messy fast.
Well, the answer is ANOVA. It's really that simple. While those z-tests and t-tests are your champs for handling pairs, ANOVA is the tool you're going to want to reach for when you're comparing the means of 3 or more groups all at the same time. It's how you scale up your analysis.
Okay, so what exactly is this thing? Well, the name itself is a massive clue. ANOVA stands for Analysis of Variance, and that's literally what it does. Let's break down what that really means. At its heart, ANOVA is just a test that helps us figure out if the differences we're seeing between the averages of all our groups are actually real, statistically significant, or if they could have just happened by pure random chance.
Now here is a super important point, and it's something that trips up a lot of people, especially in job interviews. You might hear ANOVA called the F-test. Don't let that throw you off. They are the exact same thing. Seriously, just 2 different names for the same method.
And the connection is really easy to remember. Think about it. A z-test gives you a z-score. A t-test gives you a t-score. So what does an ANOVA test give you? It calculates something called an F-statistic. That one number is the key to figuring out if your group averages are meaningfully different.
So what's the test's game plan? Well, it starts with what's called the null hypothesis. This is just the default, kind of boring assumption that nothing is going on, that all the group averages are basically the same. The whole point of the test is to see if we have enough evidence to throw out that boring idea and instead accept the alternate hypothesis, which just says, hey, wait a minute, at least one of these groups is different from the others.
So how does it figure this out without making us do a ton of complicated math? Well, conceptually, it's just a brilliant idea. ANOVA looks at 2 kinds of variation. First, it measures how different the groups are from each other. That's the variation between the groups. Then, it looks at how much variation there is inside each individual group. That's the variation within. The F-statistic? It's just a ratio of those 2 things. If that ratio is big, it means your groups are way more different from each other than they are messy on the inside, which is a huge clue that something real is going on.
Okay, so now that we've got the main idea down, let's talk about the 2 main flavors of ANOVA you're going to run into out in the wild. One-way and two-way.
A one-way ANOVA is pretty much the most straightforward version. You use it when you want to see how one single thing, one factor, or one independent variable is affecting your outcome. Think of it as looking at the impact of just one thing at a time.
So for example, let's imagine you've got 3 different classes, all taking the same test but with 3 different teachers. The one single factor you're investigating here is the teacher, and the outcome you're measuring, the response variable, is the average test score for each class. A one-way ANOVA is perfect for telling you if one of those teachers is getting significantly different results than the other.
But, the real world is messy, right? It's rarely that simple. What if there's more than one factor making a difference? Well, that's where two-way ANOVA comes into play. It lets you analyze the influence of 2 different factors on your outcome all at the same time.
Let's say you're a farmer trying to get the best crop yield. You've got 2 factors you're playing with, the type of fertilizer you're using and how close together you plant the seeds. A two-way ANOVA is amazing because it can tell you not only about the effect of the fertilizer by itself and the density by itself, but it can also spot an interaction between them. Maybe a certain fertilizer is a superstar, but only when you plant the seeds really close together. That's the kind of complex insight a two-way ANOVA can give you. So when you boil it all down, the difference is actually super simple. It's just about how many factors or independent variables you're looking at. One-way ANOVA is for 1. Two-way ANOVA is for 2. That's it.
Okay, so we've covered the theory, but why does this actually matter, like in the real world? Well, if you're thinking at all about a career in data, this next part is definitely for you.
Look, understanding the difference between a t-test and a one-way ANOVA isn't just some academic exercise. It's a fundamental skill.
When you're in an interview for a data science or analytics role, they want to know that you can pick the right tool for the right problem. It shows you don't just memorize definitions, it shows you know how to think like a real analyst.
And that pretty much brings us to the end. We've seen that ANOVA is your key to comparing more than two groups and to really understanding what's driving the results you see. So I guess the only question left is, now that you know how it works, what interesting problem are you going to go solve with it?